The Spread of Understanding by George Sarton. How impatient you are, he pats my shoulder with his heavy hand while he repeats. How impatient you are. But his kind eyes belie the severity of his voice, and he hastens to add, as if fearing that he had been too harsh. Of course that is just how it should be. Though they have so much more time before them, we must expect the younger people, especially full-blooded ones, to be in more of a hurry, to be less patient. It would be a sadder world if the young weren't tolerant. Yet listen to me. You say the world is out of joint. I have heard that before. Has it ever been otherwise? The tree-dwellers and the cavemen, I am sure, had already denounced the out-of-jointedness of their own jungle. So put it that way, if you please, but I believe it is wiser to conceive mankind as an organism, as yet undeveloped, but moving steadily from chaos to order. The progress is very slow but undeniable. And should we call it slow? How can we measure its speed? Think of it, and you will realize that to speak of the slowness of evolution is nonsense. What we really mean is that our own span of life is very short. We can see but an absurdly small part of the play. How dare we criticize it? How dare we decide whether the action is slow or not? The Great War was terrible enough. The wounds it made in millions of hearts may never be healed, but who can say how much of a scar it will leave on the fair face of the earth? It is considerably easier to destroy than to build. Why should we expect the reconstruction to be completed faster than the devastation? Why should we imagine that the world can be transformed or improved, as you say, within our lifetime? Is that not foolish? The world is not out of joint, my dear, but your telescope and your clock are out of order. Uncle Christian is one of the most lovable old gentlemen that the generous soil of Flanders has ever produced, but as the years go by, he becomes ever more opinionated and more tyrannical. Once he is well started, I know that my chances of escaping are very small, as he had now made up his mind to prove that I was wrong to expect the world to move as if its own life were hardly longer than my own. I knew that he would not let me go until he had labored his argument at least 10 times over, and I resigned myself meekly to my fate. For I love Uncle Christian, even if he drives me mad. And then his knowledge and his wisdom are very great, and it is worthwhile to record at least the gist of what he said, but as he is hopelessly discursive, and as I could not possibly reproduce the saving humor of his tone and his smiles and gestures, it will be the best to tell the story in my own way, not one story, but 3 stories, for the old man is nothing if not thorough. As a matter of fact, he told me 7, and he would have told as many more, but that I admitted he was right and promised that I would be more patient in the future. The first story. One of the greatest discoveries man ever made is that of our numerals, but we are so familiar with them that we take them too much for granted. Yet if you begin to think it over, is that system not very admirable, which enables us not simply to write down any number very quickly and without ambiguity, but also to use those numbers in our computations to manipulate them according to a few fixed rules for any length of time, almost mechanically, and to obtain finally another number written in the same shorthand and representing the very result which we had started to find out. To be sure, we might have obtained the same result by counting with pebbles, but that would have consumed far more time. It would have been on the whole more difficult, our chances of error greater, and the errors themselves harder to detect. Our system of numerals is not so simple as it seems to be, for it involves at least 3 distinct ideas. To consider first the most conspicuous but the least important of them. We use only 10 symbols to write any number, that is, our system is decimal. The beauty of this is that the number of figures is so small, it might have been smaller still. A system of 8 figures would have done very well, or else a little larger, 12, would have made an ideal set, but not much larger without sensibly increasing the difficulty of computations. For in the case of a duodecimal system, our children would have to learn by rote their table of multiplication up to 12 and so on. Why did we choose 10? The reason is simply that our ancestors made their family accounts on their fingers or on their toes, and they happened to be, just like ourselves, 10-fingered and 10-toed. 10 thus become 10 thus became naturally the basis of our numeration. It is true that some other people developed other systems. The Babylonians used the basis 60, and the Mayas, most intelligent of the original Americans, the basis 20. However, the basis 10 is now almost universally used, at least as far as the numbers themselves are concerned. The second idea is what we now call the principle of local value. That is the very heart of this immense discovery. When we write 324, for example, we mean to represent a collection constituted by 4 units, plus 2 tens, plus 3 hundreds. We know at once that 3 stands for hundreds, for it is written at the third place from the right. If it were written at the 7th place, it would mean 3 millions. The third idea is, so to say, an elaboration of the second. What would one do if there were no units of a certain order? How should we write 3 millions and 4 hundreds, for example? One might leave an open space between the 4 and the 3, and another between the 3 and the final dot, but that would be very ambiguous. Some unknown genius, or maybe many, hit upon the device of creating a special symbol, the 0, representing no number, but to be used only to mark that units of a certain order were missing. Thus, if we write 3,400,000, there can be no misunderstanding. A careful definition of the new symbol enabled us to use it exactly as the older ones without further ado. It seems that the Mayas knew the use of it, but they did not think of the decimal system. When, then, did the latter, that is, the combination of the 3 ideas, originate? It is very probable that it originated in India sometime about the 5th or 6th century, if not earlier. The system was already known in western Syria about 662. The Muslims, who transmitted Greek, Hindu, and Iranian knowledge to the Christian West, introduced also the new numerals, which are often called Arabic numerals because of that. Yet it took the West a very long time to understand and to assimilate them. The earliest coin bearing the Hindu numerals is one with the Arabic legend struck in 1138 to commemorate the reign of Roger of Sicily, but the conditions obtained in Sicily where Byzantines, Latins, and Muslims met on an equal footing were too exceptional to be representative of Western Europe. However, by the end of the 12th century, a small elite was apparently familiar with the new system. Their formal and final introduction was due to Leonardo of Pisa, who published in 1202 a book containing a very clear explanation of the Hindu numerals and of the best ways of using them. Mind you, more than 6 centuries had already passed since this discovery, and as far as Europe was concerned, this was only the beginning, the first satisfactory and successful introduction of the subject. At the close of the 13th century, the bankers of Florence were forbidden to use these numerals, and we may gather that they actually used them, but in the face of a strong opposition. The only alternative was the clumsy Roman notation, which offered a means of writing numerals in a manner unequivocal but very unclear. It was altogether out of the question to use them for any but the most simplest reckonings. One might say that the Roman numerals could be used solely because they were not used. All calculations were actually made by some kind of abacus or calculating table, and only the results, partial or final, were put down in Roman letters. The calculations themselves were lost in the sand or vanished with the motions of the counters. The heroic period was now long over, and the rest of the history of our numerals is but one example among so many others of the difficulty of overcoming the enormous inertia of vested traditions. The case is interesting because the new decimal system was a time and labor-saving invention of the first magnitude. The Hindus had made to mankind a gift of inestimable value. No strings of any kind were attached to it, nor was the suggested improvement entangled with any sort of religious or philosophic ideas. Those proposing to use the new numerals were not expected to make any disavowal or concession, nor could their feelings be hurt in any way. They were asked simply to exchange a bad tool for a good one. Yet it was not until the 14th and 15th centuries that the new system was generally accepted in Italy, and not until the 16th and even the beginning of the 17th that it was finally established in the rest of civilized Europe. All counted, more than a millennium had elapsed between the discovery and its general acceptance, even in that primary stage. In the meanwhile, it is true the center of civilization had moved from southern Asia to western Europe, but that had not been the cause of the delay. Mountains and seas and even desert plains are smaller obstacles to the diffusion of ideas than the unreasonable obstinacy of man. The main barriers to overcome are not outside but inside the brain. The second story, which is very different and yet not so different. It is well known that the circulation of the blood in the human body was satisfactorily explained for the first time by William Harvey. The first idea of this discovery occurred to him not later than 1616, but he did not publish it until 1628 in a little book dealing with the motion of the heart and blood. One is rather surprised to find that this book did not make any more stir. Neither did it arouse much opposition, at least in England. In France, the opposition to the new theory was considerable, but even there, and bitter as it was, it did not last very long. More happy in this than many other forerunners, Harvey was granted a taste of victory before his death in 1657. By 1673, his cause was definitely won even in France, and the people who had been his contemporaries could witness the complete supremacy of the new doctrine. Thus, less than half a century had been needed to ensure its triumph. The speed of this reception is less wonderful, however, than the lateness of the discovery itself, for as to Harvey's priority there can be no doubt. How is it that no one anticipated him? There was nothing whatever in the nature of this discovery, as Harvey made it, to prevent its being made many centuries before, nothing but prejudice. Until the time of Harvey, the prevalent conception was that promulgated by Galen more than 14 centuries earlier. It is not easy at all to give a complete account of Galen's ideas, but it will suffice to note the following points. According to him, the blood was produced in the liver from the materials furnished by our food and was then transported to the right half of the heart. Some of it passed into the left half, where it was imbued with new properties and became fit to nourish the whole body. To use Galenic language, the blood of the right heart was endowed with natural spirits, that of the left heart with vital spirits. The latter blood was thus essentially different from the former. They did not circulate in the body, but both moved in a ceaseless ebb and flow, each in its own domain. But how did the blood pass from the right to the left ventricle? To explain the impossible, Galen had been obliged to assume that it passed through innumerable invisible pores in the solid wall which divides the right from the left. Nobody ever detected these pores, for they are not simply invisible and non-existent. Yet Galen, supreme pontiff of the Greek medicine, and 9 centuries later, Avicenna, the infallible medical pope of the Middle Ages, had spoken ex cathedra with such indisputable authority that this gratuitous assumption was generally taken for gospel. Even a man like Leonardo da Vinci, endowed with so much genius and originality, and who had himself dissected a large number of bodies and examined very minutely many a heart, even he was subjected by this intangible dogma. This is the more pathetic in that Leonardo was certainly on the scent of the true explanation, but the invisible holes were too sacred to be touched, and nothing but this prejudice caused his failure to discover and proclaim the circulation of the blood. When I shut my eyes and evoke the past, I imagine that this great discovery was enclosed in a chest of which intelligent observers like Leonardo, Vesalius, Servetus, or Columbus could have easily found the secret if they had set their hearts upon it, but they did not dare approach near enough because prejudice sat on the lid. I can see those great men standing shyly around the coffer, mysteriously attracted by it, yet awed into impotence, while truth was prisoner inside. A moment of reflection will now convince you that the second story is not so widely different from the first as it might appear at first. In both cases, the application of a great discovery was delayed for more than a millennium by unreasonable prejudices. But in the first case, the obstruction occurred after the discovery and prevented it from becoming effective, while in the second, prejudice blocked the way to the discovery itself, preventing it from being made. This third story, which is in some way a sequel to the first. Prince Maurice of Nassau, Stadtholder of the Low Countries, took into his service about the year 1593 a Fleming of considerable genius, Simon Stephen of Burgess. He used to refer to him for mathematical advice and employed him as his chief hydraulic engineer and as quartermaster general of his armies. This Stephen was not yet received his full meed of recognition for he certainly was one of the greatest men of the 16th century. Various important discoveries or inventions are ascribed to him, and the historian of mechanics can quote no greater name for the whole interval of more than 18 centuries between Archimedes and Galileo. In the year 1585, Stephen published in both a Dutch and French edition a little book entitled The Tive, wherein he gave for the first time a systematic account of decimal fractions. The Tithe, T-I-T-H-E. Though he was not the first to think of such fractions, he showed such a deep understanding and gave such a masterly exposition of them that he will not be far wrong if we call him the inventor. His manner of representing them was rather clumsy, however, and that might have delayed their diffusion had this brilliant innovation not been reinforced a little later by another invention at least equally important, that of the logarithms. The logarithms, like the decimals, made it possible to increase considerably the speed of computation. It has been justly said that the discovery of logarithms doubled the lives of the astronomers. They were introduced at the beginning of the following century, 1614-1619, by John Napier, Laird of Merchiston, who showed us at the same time a far simpler method of representing the decimal fractions, the very one we use today. The triumph of the logarithms was immediate. No amount of prejudice could have prevented the astronomers from doubling their years, and their decimals shared the triumph as a matter of course. But here again our surprise is not that these fractions were accepted so readily, but they were offered so late. Indeed, what did they stand for? Just as the main idea of the decimal system was to collect the objects to be counted in tens, tens of tens, or hundreds, and so on, so the gist of the decimal fractions was to count fragments of unity similar in tenths, tenths of tenths, or hundredths, etc. When this was consistently done, it was found that those fractions could be written and used almost as simply as ordinary numbers. The decimal fractions, so to say, drove the fractions out of our calculations, and the more so that one could always suppress them altogether if one wished. If it annoyed you much to speak of $3.53, you could say without changing a single figure, 353 cents. The decimal fractions are so simple that most people can handle them without being aware of their presence, just as Monsieur Jordan spoke in prose without his knowing it. The most convincing proof of Stephen's genius was perhaps that after having explained the decimal fractions, he did not rest there. He saw at once the logical consequences of their introduction and the immense possibilities which were involved. Decimal numbers are naturally introduced when we enumerate objects if we account them by tens, but what will happen if our numbers are the result of a direct enumeration, but of a mensuration, as when we want to know the length of a piece of cloth or the weight of a cheese? Then it is clear that we can only obtain the same fractions that are included in our instruments. Thus, if we deal with feet and inches or shillings and pence, we are driven to use duodecimal fractions which do not at all tally with our decimal system. Stephen was the first to realize that the adoption of a decimal system of numbers led irresistibly to that of a decimal system of weights and measures, and vice versa, and that neither adoption was truly complete without the other. To measure according to one system and to count according to another destroyed the economy of both. This great vision of Stephen's was beautifully simple as it was deep, yet it was not embodied until the 18th century, when the French Revolution created the so-called metric system. The idea was accepted by the Assemblée Constituante in 1790, and the system became legally established in France. During last century it spread all over the world, except strangely enough in the Anglo-Saxon countries, where it met and still meets with a resistance which is the stronger in that it is irrational. In the 15th century there were still any number of learned doctors and professors who claimed that the Roman letters were much clearer than the Hindu numerals. Was it not much simpler to write Roman numeral CCCXLV111 than 348? In the same way, there are still many English and American apostles full of learning who will prove to everybody who will listen that their incongruous sets of weights, measures, and monies are much more convenient than the metric system. How can they do it? I really don't know, but they do it with a fervor only equaled by the paradoxical absurdity of their plea. A Frenchman needs no fraction but the decimal, and these can take care of themselves, so to say. He hardly notices them. On the contrary, your Englishman uses vigesimal fractions. If he speaks of pounds sterlings and shillings, both Americans and Englishmen need duodecimal fractions when dealing with feet and inches, and sixteenths to measure in pounds, avoirdupois, and ounces, and many more varieties, each of which seems to be entirely independent of the others. The factor 10 is about the only one absent from his tables of weights and measures, yet he clings faithfully to the decimal system of numbers. It looks as if, after having admitted the superiority of these numbers, his need of order had been exhausted, and he stopped short, discouraged on the road of improvement. When Uncle Christian had reached this point of the story which he was telling in order to instill into my own soul the noble virtue of patience, he became so enraged that he could hardly master his feelings or choose his words. "Think of it. Try to visualize this great discovery made in India about the 6th century, perfected in the Low Countries in the 16th, completed in France at the end of the 18th, one of the greatest labor-saving discoveries which the human race has ever made. Can you imagine that the nations which are in many respects the most civilized of our own times have not yet grasped its importance? The work of more than 10 generations has not sufficed to convince them with regard to a truth of the simplest and most objective kind. It makes me mad to think of the time which the children must need to become familiar with those grotesque assortments of weights and measures, as if they were not yet sufficiently handicapped by the most erratic spelling of all languages, dead or alive. Poor children! It did not matter so much in the past, when they had but little to learn, but now that we cannot find enough time to teach them the essentials, it seems almost criminal to waste their attention upon such artificial knowledge. For even if they should know all the relations between those measures and all the eccentricities of the English dictionary, and even, if you please, the peculiarities of many other languages, would they be able to understand the whole world any better? Certainly not. They might just as well have memorized the telephone directory. For example, to know that you must spell knee and pronounce N-E-E is no real knowledge, for it does not teach you anything about the nature of things in general or of knees in particular. This gives one at best a clearer notion of human perversity. It can give one no knowledge of nature, no understanding of the cosmos. Poor little children, victims of the insane obstinacy of their elders and of the ignorance and lack of imagination of their educators. Uncle Christian is so overcome that he will not talk any more. It is my turn now to soothe and humor him. Soon he will recover his enthusiasm and maybe his voice. To be sure, in the domain of pure science, progress has now become far more rapid because the value of discoveries is no longer judged by the crowds from an irrational point of view, but by experts from a purely technical one. Even the most revolutionary theories, such as radioactivity, the quanta, or relativity, are examined quietly by a very small body of scientists who are kept constantly on their guard by mutual criticism, and who are expected to justify their every opinion. Their verdict, whichever it be, destroys any irrational obstruction in the egg. Unfortunately, such improved methods can be used only in the case of problems amenable to scientific treatment, without any philosophic or sentimental loophole, and which are of sufficient technicality to be beyond the reach of meddling people. In the field of technology, though so close to that of science, new ideas may be jeopardized, or their success considerably delayed, by various irrelevant circumstances. This explains why the proper launches of an invention is so tremendously important, but when it comes to social or political problems, not to speak of religious ones, it is almost as difficult to obtain a proper appreciation of them as it was in the Middle Ages. Indeed, a large number of the non- or half-educated people, even of the most enlightened nations, are still intellectually in the medieval stage. That is, they are uncritical, unable to judge matters dispassionately, unable to disentangle the truth from its web of prejudice. We should not, in our turn, judge them too severely, for even the greatest heroes of truth were not entirely untrammeled. It humbles our minds but mollifies our hearts to realize that each of them, after having fought gallantly, one after another, the errors and the prejudices which lay ambushed along his way, was finally checked by some imaginary obstacle which he could not overcome, by a last prepossession which he durst not challenge.